Hello, welcome to a series of lecture we're going to do on static. Static is a really good course. It's a foundation for a lot of classes, especially structural engineering, geotechnical engineering, transportation engineering, and you name it. There's a lot of good stuff you're going to learn here. In my graduate classes, I normally refer to, I tell my students, yeah, you learned this in the kindergarten. So this is basically a kindergarten for all of those advanced classes. You learn this basic stuff, it's important, it will pay off. Well, what is a static? Let me show you on a PowerPoint here. You look at the mechanic of material, you know, that's in mechanics itself. It's going to subdivide to a rigid body, deformation body, and fluid. In a rigid body, you have a static and dynamic. That's what we're going to deal with, is static. And we're going to start out with the mathematic of static. It's really important to understand this basically. You probably had this in high school anyway. And let's go over it again so you kind of get it done and get it ready. When we look at the mathematics of statics, knowing the triangle and equation and law of the sine and cosine comes in very handy. These triangles you will be using in future classes, whether it's a structural engineering or geotechnical or transportation. So there are three triangles we use in static quite a bit. One is a right triangle. You all seen this in high school. The other one is an obtuse triangle, oblique triangle, and the other one is a oblique triangle with the obtuse angle or an acute angles right here. The looking at the right triangle, as you had this long time ago in kindergarten, high school, you look at the sine of theta, you have look at all the different sides. If you call this hypotenuse, and this will be side adjacent and side opposite, so your sine of theta will be side opposite divided by hypotenuse, and cosine theta will be side adjacent divided by hypotenuse, and tangent, which will be quite a bit where we use that when we come to a vector, it'd be opposite side divided by adjacent side. You look at the angles right here. You have right angle, which is 90 degree. Obtuse angle is more than 90 degree. And acute angle is less than 90 degree. And then you have reflex, which is more than 270. The oblique triangle has two laws. You want to know these two laws. One is a law of cosine, the other one is law of sine. If you look at this triangle right here, you got length of A, could be 10 feet, 20 feet, 2 meters, whatever. Opposite of that, it called angle A. This will be B, opposite angle B. This will be C, opposite angle C. And this will be used, so A squared is equal to B squared plus C squared minus 2 times BC times cosine angle between them. B and C, it's right there. And then we have a law of sine, which is basically the length of A divided by sine of A, length of B divided by sine of B, length of C divided by sine of C. We will use a bunch of examples to go over these to kind of familiar ourselves with it. All right, we're going to look at this example right here. We have this ladder. The ladder itself is about 14 feet tall. It's put against the wall. We like to know what the height of the wall right here is. So we put the ladder about 4 feet away from the wall. And you can see the diagram here. Then what is the height of the wall? That's what basically is. And if you know, we can use a Pythagorean theorem. And a Pythagorean theorem we showed in a PowerPoint was basically C squared is equal A squared plus B squared. C always is this hypotenuse length right here, this side. And if we go ahead and rearrange that, we say, okay, that's A squared is equal C squared minus B squared. Let me shut this off so you can see it better. All right, so we're going to plug in our A squared is equal C squared was 14, that's 14 squared, minus B is a 4 squared. That gives us 180. And then A comes out to square root of 180, which is about 13.42. So this is a 13.42. The next problem we have is this roof truss. As you can see right here, we want to know what is the height of the QS and also the length of QR. We want to know this length and this height and also this angle right here. So the only information we have so far is this is it, what you're looking at. What we have here is we got, look at this triangle right here, the first one, this one. Okay, look at this triangle, basically is right here. And we can see that if we take a tangent of 35, and that's equal the opposite, which is a QS, divided by side, which is a 32. And there it is, we can find QS from here. So I can say QS is equal, let me shut this off so you can see it better. QS is equal, that's a 32. You put a 1 underneath here, you could basically cross multiplication. 32 times tangent 35. And that should come out to 22.4 feet. Double check there, that I make double check it myself too. So now we know that this is going to become basically 22.4. Next thing we want to know, QR, you got a right triangle right here, and this will be hypotenuse, and therefore we can say WQR. So I'm going to say, I can say Q, let me see so you can see that, R square is equal this side square, which is a 16 square, plus 22.4 square. And that comes out to become 758 feet. But we like to know what QR is. So QR is equal to square root of 758. That will give us about 27.5 feet. So now we found out this is equal 27.5 feet. What was the last question? The last question was the angle of R. They want to know this angle right here. Okay. Let me change color. And what we're going to do, we're going to come up to tangent of R right here, which would be opposite divided by side. So I'm going to come in here, say tangent R is equal, opposite was 22.4 divided by 16, and that will give me 1.4. Now I have that, I can say R is equal tangent inverse of 140, which you can plug in a calculator. So our R comes out to be 54.5 degree. There's more than way you can do this. The other one you can do, you can use a sine. Let's use a sine, see if we're going to get the same thing. R is equal, I'm just going to go ahead and do it completely. Sine inverse, the sine will be what? It will be the opposite divided by hypotenuse. So the opposite is 22.4. 22.4, that's the opposite. And divide by hypotenuse, which is 27.5. Plug that in a calculator and you're going to find out, yep, same thing, 54.5. Okay, let's do this one more problem right here. You got this, you can read the problem, and basically want to know what is the height of the tower is. And the angle is given. Let me shut this off. There we go. So now we have this situation, one person looking from here at the angle of 68 degree and 10 minute and looks down at point C. Another person looking at right here at 72 degree and 30, this right here. The only thing we know, the distance between here and there, A and B, is 300 feet, and we know the angle and we know nothing else, but we don't know what height it is. This is something like a kindergarten engineering should know this. And you learn these mathematics of engineering, and it's really good. It's easy stuff. Somebody asks you like that, they go, wow, you're awesome. And you say, yeah, of course I am. I did all this. So one of the first things we're going to do is, we know all the triangle, all three sides of triangle comes out to 180 degrees. Let's find out what this angle is. It's about, we're going to say angle, that'd be C. Angle C is equal 180 minus 68 and 10. Let's convert this 68 and 10 to minute. I mean, that's a 68 degree and 10 minute. That's a 68, 10. So 10 divided by 60 is 0.17. So if I divide this 10 by 60, so I get 68.16. And then this one, 72 and 30, that becomes 72.5. All right, so that made it easy. Let me come back in here. And we're going to have 180 minus 68.16 minus 72.30, or 72.5. And that comes out to be 39 degree and 20 minute, or 39.33. 39.33 degree. So I'm going to come back right here and write this down here, 39.33. So we got one thing done. Take a look at the board. We talked about the law of, actually let me bring it up, see if I can bring it here. So we're going to use a law of sine and law of cosine. Take a look at these, and that's what we're going to use for now. We're going to use these to figure some stuff out. Let me go back to the other way. There we go. Law of sine says A over sine A is equal to B over sine B is equal C over sine C. So we have 300 divided by sine of 39.33 and is equal A divided by sine of 68.16 is equal B divided by sine of 72.5. If we use those, then we're going to have simple calculation. A comes out to be 439.6. So A is 439.6 feet. And B comes out to be 451.41. And that's a 451.41 feet. Okay. Let's look at this triangle. Let's find this angle first here. This angle is 90 degree minus 68.16, and that will be 21.84. Good enough, right? So what is the sine of A? This triangle I'm talking about right here. What's sine of A? Is opposite divided by hypotenuse. Remember? Sine A is opposite divided by hypotenuse. So I'm going to say sine A this A. So sine at 21.84 is equal, opposite, which is the DC, I don't know, divided by hypotenuse, which I know, 451.41. So DC is going to come out to be 167.88. You could do the other way, calculate EC and look at this here. But I'm going to go right here. Remember, we're going to look at the Pythagorean theorem. It said C squared is equal A squared plus B squared. In our case, this is a B squared. Let me change color for good luck. So I got B squared equal DC squared plus AD squared. I want to know what AD squared is. If I plug a number, that becomes 451.41 squared is equal DC, which we know, we just figured it out to be 167.88 squared plus AD squared, which we don't know. Therefore, I can say AD is equal square root of 451.41 square. Let's put a parenthesis around it and put this square right here. Minus 167.88 square. And that comes out to be 419 feet. So our tower height come out to be 490 feet, and that's how it's done. I hope you like this. Give it a thumbs up or subscribe. These are important. You know, you just have to work at it, look at the mathematics, the triangle this way, that way, and you can solve the problem. Have a good day. I'll see you in class.